Taking a look at number 15 from the Unit 7 review, I'm going to write this down, y equals, by the way, this is like a -1. If you see a negative sign in front, it's like -1 times 2 raised to the x minus 3 plus 4. Keep that in mind. So whenever we find a y-intercept, the opposite variable, in this case x, will always be 0. So I'm just going to come up here and replace x with 0. There's no such thing as -0, so it's just 0. I have -1 times 2 raised to the -3 plus 4. Okay, so I have -1. Now, I know that this says it's not happy. I can see that this is not happy. So I'm going to make it happy. It was on top, it goes to the bottom, and now it's happy, plus 4. I'm going to demonstrate how we could get this answer if we couldn't use a graphing calculator, but I will show you on a graphing calculator as well how we could do this. So -1 times 1 over 8, because 2 times 2 times 2 is 8, plus 4. A negative times this quantity is a -1/8 plus 4. Now, I'm going to choose at this point just to go ahead and use what he calls a McFarland method. You may want to call it the butterfly method. You may even choose to do the old school way of finding a common denominator, and that would look like this. I know that when I add or subtract fractions, I need to have the same denominator. So now this is the same as 4. 32 over 8 is just the same as 4. So when I combine, I have -1 plus 32. That's 31 over 8. There we go. So we have a y-intercept, x is always 0 for a y-intercept, and 31 over 8. If I look back, yes, he does want you to leave it as a fraction. We can see that if I turn it into a decimal, if we turn it into a decimal, it could be 3.875, but he does want to see your work. I want to stress that he does want to see all of your algebraic work for this. Now, just the opposite for 16. Instead of finding the y-intercept, I'm finding the x-intercept. So when I find the x-intercept, y must be 0, and y is the same as f of x. I'm going to replace f of x with 0, so 0 equals 3 times log base 4 of 2x minus 3 plus 6. And now I want to solve for x. So I want to get this portion by itself, and I'm going to reverse PEMDAS. So please excuse my dear Aunt Sally, I'm starting at the very bottom when I'm solving for a variable. So I'm starting with, can I add or subtract anything to get this portion by itself? Subtract 6 to both sides. And then I'm going to divide by 3. -2 equals log base 4 of 2x minus 3. All of that is wonderful. And now I'm going to go back to rewriting this in exponential form. So the base of the problem is 4, and I raise it across the equal sign. We normally see equals -2, but it can be the other way. I raise it across the equal sign to the opposite number, and that becomes the exponent, and then whatever is directly behind the base is the answer. So I need to see, showing algebra, how do we get this? Well, 4 is not happy. Why is it not happy? Because the exponent's negative. So 4 squared is now on the bottom. It's happy it's been moved. I know 4 squared is 1 over 16. Now I'm going to add 3 to the other side. So I'm going to go plus 3 and plus 3. So 1 over 16 plus 3 equals 2x. Well, they're really going to challenge us in this problem of doing kind of that basic math that we've learned 5th, 6th grade that kind of just takes a lot of time. So you could do the butterfly method here, and I can demonstrate how to do that. To do the butterfly method, we're going to do, or you could do like times 16 times 16 and do the same thing I did in the previous problem. But this is what the butterfly problem, I call it butterfly, he calls it Mr. McFarland. Butterfly method looks like this. I'm going to multiply. This symbol goes right here. Well, if there's subtraction, subtraction would go here. I'm going to multiply these two. You always start with this diagonal first. So the numerator of the first always has to go first. 1 times 1 is 1. 16 times 3 is 48. And now the product, I multiply the two bottom, in this case, to come up with 16. So I have 49 over 16. That's what I have on the left-hand side, equals 2x. And if you didn't realize this, when you solve for x, like our natural thing is divide by 2, and then there's confusion. When you divide by 2, it's the same thing as multiplying by 1/2. Multiplying by 1/2 is actually just dividing by 2, so I'm going to multiply by 1/2. The 2's, you want to think canceled in your mind. Really what they do is the 2's are going to simplify into a 1, and I'm left with x. And now I just multiply. So I multiply across. 1 times 49 is 49. 2 times 16 is 32. And that's how I end up with 49 over 32. 49 over 32. A lot of that basic math that used to confuse students long ago, and still probably confuses students. It's very detailed. It's easy to make small mistakes with that.